Hi everyone, now we will continue our next lecture on mathematical functions, characters and strings. Please let me know if you can hear me and if you can see my screen well enough. Excellent. Yes, please. Okay, so we'll start with the definition of a static method. Remember the method main that we wrote for several programs by now? This method main had a signature that was public static void main with an array of arguments as a parameter. What does the static keyword means in this case? It basically associates this method with a particular class. So it basically makes this method not a method that is called for individual objects that we will have in the future that we basically instantiate out of this class. We can call this method directly, either with the class name or within the current class. So for instance, the main method is a static method. There can be as many methods as possible. You basically can define variables, you can define methods, you can use methods from other classes as long as those methods are static methods. And we will go first to learn the main static methods that are available in the math class. In the math class, we have methods to compute trigonometric functions, to compute exponent, to compute rounding, to compute the maximum minimum within different type of values, like the maximum of 2 integers, the minimum of 2 doubles, and so on, to generate random values or pseudo-random values, which basically are connected to some function applied to either random inputs collected from the network card or to various locations on the screen, pixel values or locations of objects and so on. So first we have the trigonometric methods. If we want to compute the sinus, cosinus, tangenta, a cosinus, a sinus, a tangenta for any number of radians, we can pass those number of radians as a parameter to the math dot sin, cosinus, tangenta, a cosinus, a sinus, tangenta methods. So for instance, if we want the sinus of 0 radians, we can basically invoke math.sinus of 0 and it will return 0.0. For the math class in Java, you do not have to basically import anything. So you can basically just use math.sinus, math.cosinus. So let's actually do an example. System.out.println math.sinus of 0. That basically computes the sinus of 0 radians, which in the case of sinus, it basically is 0.0. You can also compute the sinus of math.pi. Pi is a constant defined in the same class math, so it will actually compute math.pi or sinus of math.pi. If you want, you can compute the sinus of math.pi divided by 2, which is 1.0. The sinus of 90 degrees is basically 1.0. So in similar ways, you can compute the sinus of different angles. You can compute the cosinus of different angles. You can compute the tangent of different angles. Another set of methods, also imported by default, if you need them from the math class, are exponent, logarithm, logarithm in base 10. Logarithm by itself is the natural logarithm of a of any input a double. The power, you can raise any number a to the power b, the square root of a number a, and so on. So for instance, if you want what is e to the power 1, you can use the exponent is basically the e to the power 1 is 2.7. A math.logarithm will compute the logarithm of a number, math.power will compute the power of a number. Map.square root will compute the square root. So square root of 4, for instance, is 2. And you can compute the square root of any number that you would like. So let's do a few examples. Let's assume that I want to compute map.square root of 9. It will print, in this case, 3.0. Basically, that is the square root of 9. Rounding methods. Again, from math, we want to use basically rounding methods to find the nearest integer greater than equal with a double x. So x will be rounded to the nearest integer using the ceiling function. It returns a double, so be careful. Although you are thinking that it may always return an integer, the return type for the ceiling function is actually double. So is the closest integer, is the nearest integer greater than equal with x, but represented as a double. Similarly, the floor will return the nearest integer less than equal with x. Rint is x rounded to the nearest integer. If it's closely equal to two integers, it will return the even one. So for instance, rint of 4.5 will return 4. Rint of 5.5 will return 6. Round returns exactly the value that you have below, is the integer value after we apply map.floor of x plus 0.5. And round of a double will return a long, because doubles are 8 bytes, so it will return an equivalent integer type. And here we have a couple of examples. The ceiling of 2.1 is 3.0, the ceiling of 2.0 is 2.0, the ceiling of minus 2.0 is minus 2.0, the ceiling of minus 2.1 is minus 2.0, because these are negative numbers, minus 2.0 is greater than minus 2.1. The floor of 2.1 is 2.0, so is the floor of 2.0. The floor of minus 2.0 is minus 2.0, and the floor of minus 2.1 is minus 3.0, and so on. Basically, you can apply the round and the rint functions. Maximum, minimum, and absolute value are basically methods that are overloaded for different types. They basically, if you invoke them with two integers, it will return the maximum of the two integers. If you call them with doubles, it will return the double value that is the maximum of the two values. So you see that in this case, it actually transforms the integer 3 into the integer 3.0, because the first argument of this function was a double value. Absolute value returns the absolute value of the parameter, so minus 2 will return 2, of minus 2.1 will return 2.1, because again it's overloaded. For different input types, it returns the corresponding absolute in that input type. Random is a special function. Random returns a random value between 0 and 1.0. So for instance, if we call random multiple times, it will always return a value between 0 and 1 as a double, and every time is a different value. So we can run it 10 times, and we see that we have different random values. The random value is a value between 0 included. We can actually get 0 and 1 not included. So it returns a double random number between 0 and 1.0. The random number method can be used to return also integers. Let's assume that we want to return an integer random integer between 0 and 9. What we can do is we can multiply map.random with 10. That will give us a number in the interval from 0 to 10, not including 10. And then we can cast it to integer. That will return a random integer between 0 and 9 in that discrete set. So for instance, if we want 10 random integers, all that we need to do is to specify casting into integer of map.random and multiply it with the range let's say that we want random integers between 0 and 9. So that will give us the integer between 0 and 9. If we want it once, it will give us 1. If we want, let's say, 10 of them, it will give us 10 random numbers between 0 and 9. So we can see that we have 8, 4, 4, 0, 0, 9, 6, 3, 3. There is not a large range, so there can be basically, with random probability, different numbers. And every time you run it, you will get a different set, because these are really random numbers. They don't use any kind of like special function. Internally, yes, they are actually using random signals from different interfaces, but they basically, you can't predict what numbers are they. Let's say that we want values between 1 and 10. All that we need to do is to add 1 to the result that we got in the previous case. So in that case, we basically get a shift into basically a different area from 1 to 10 instead of from 0 to 9. So now we get random values from 1 to 10, including 10. In many, many cases that we previously ran, we also have 10. So that will return a random value. So if we want in a different interval, we can add a value to it, like 50, and a random value up to 50 will give us values between 50 and 99. In general, if you want a value in an interval, or basically from a to a plus b, you can add a to math.random multiplied with b. What about if you want to generate random characters? You can consider that characters are encoded with the Unicode encoding of that character. So if you take that Unicode encoding as an integer, and you multiply the distance between z and a with math.random, it will give you, from the position of a random shift within the alphabet. If math.random was 0, then you basically get the character, you get 0 multiplied with the range, it's 0, and you're getting the character for a. All the numeric operators can be applied directly to character operators, so you don't really need to cast the characters to integers before we apply this function. So you can actually just add a with math.random multiply with the distance between z and a plus 1, and that will give you exactly the range from a to z. After you apply this function, you basically get here a double value, because math.random is a double, and you can cast the entire result to a character, which will give you random characters between a and z. So let's do exactly the same to see it actually in action. So we want a character, a random character, and again we will start, let's say, from the character in the range from z to a minus 1, and we are adding the character for a to it. So this will basically generate a random character that will be printed. Now it's printed as a number, and the reason why is that we actually added this character outside. So we are actually adding 2 characters, which gives us a number. If we want a character, we have to put it within the cast. The cast started here and ended here. So now if we print it, it gives us random characters. And again, we can actually print as many as we want. It will generate as many random characters as we basically want. You see, all of these are random characters. If we want an uppercase character, all that we need to do is to change the range from lowercase to uppercase. So again, we can take that previous statement and generate random uppercase characters. And of course, it generates always random characters. The ASCII codes for commonly used characters basically are 48 to 57 for digits, from 0 to 9, 65 to 90 for characters from uppercase A to uppercase Z, and 97 to 122 for lowercase a to Z. However, you don't really need to remember any of these numbers because you can always use in any mathematical expression characters themselves. So you don't need to know the the Unicode for lowercase a because you can use the lowercase a whenever you need it. Similarly, you don't need to know any one of the character codes that we saw before because randomly you can basically, you can just use the character itself. If you want to check if a character is within some range, you can basically just compare the character with the greater than equal operator with the other character. Like for instance, if you want to see if a character variable ch is an uppercase letter, all that you need to do is to check that it is the case that uppercase a is less than equal with the character ch, and ch is less than equal with uppercase z. That will only happen to be true for uppercase characters, basically from A to Z. Similarly, if you want to do a check for lowercase or numeric characters, you can just compare the character with that specific value. Now there are also defined methods, also static methods, in the character class. So the same checks that we basically can make with an if statement. So for instance, if we want to check if a character is lowercase, let's say that we do have a lowercase letter, and we have a boolean. This boolean, let's call it check, is that comparison that lowercase a is less than equal with the character ch, and the character ch is less than equal with the character z, and we print the value of check. It will print true because it is indeed the case that ch is between a and z. But the same check can be done in a different way. We can use the character class. The character class basically contains already methods for checking if a character is a digit, if it's a letter, if it's in lowercase. So we can actually use character dot is lowercase with that character ch. The output of this method is exactly the same as the statement above. So in fact, those two are equivalent. Okay? Basically checking manually if the character is in that range with a conjunction or comparisons, or checking using the character class method, a static method is lowercase, are equivalent, are exactly the same. That method has exactly the same implementation. So let's talk about strings. Strings are a little bit different. The string type can represent more than just one character. The character type cannot represent sequences like A, B, C. Those are not basically representable by a single character. To represent a value like A, B, C, we need to use a string. We can write it as a string variable, let's call it S, is a new string that contains A, B, C. And later we can actually print the value of that string. And it will print ABC. So strings can represent sequences of characters like welcome to Java, ABC, and so on. The string type is not a primitive type. Basically, if you try to compare two strings, it will only succeed if the two string variables are the same variable. if you compare it with double equal operator. The reason why is that string type is a reference type. A string variable is a reference to an address, is basically an address which points to an object that stores that actual value. So it's not really a value at the location of that specific variable. So, for instance, in a string has associated a lot of methods. You can get a character at any index within the string, has methods to process the string, you can get the character, you can convert the string to uppercase, you can extract a substring from the string, a slice of the string, let's say from index 0 to 7. So it's always useful to take programs from the lecture notes and actually try them on your own to learn through practice how to program in Java. So I'm going to do exactly the same thing. I'm going to define a variable s, which is equal with a statement. And every single method that we are going to test this class, I'm going to write it in this method. So let's say that I want to extract the character at index 0. So the character at index 0 in a statement should be just the letter A. If I want the character at index 1, basically starting from the beginning of that string, every character has an index. So A has the index 0, space has the index 1, S has the index 2, T has the index 3, and so on. So for instance, if I want to extract T, I can ask, give me the character at index 3, and so on. Basically the rest of the characters. So if I run it, it will print that the character at index 3 is T. So every character is stored at an index that starts from 0 from the left-hand side, and we can extract that character. If we want, again, the string class has a lot of methods. If we want to get that string in uppercase or lowercase, we can again use methods. So system.out.println, give me from that string the whole string in uppercase. And that will print a statement with all letters in uppercase. If I want to extract a slice, let's assume that we want to extract a state. So it starts at index 2 and it ends at index 3, 4, 5, 6, 7, not including 7. So give me system.out.println, give me from the string s the substring starting at position 2 and ending at position 7. So that will print state. Basically, starting from position 2 up to position 7, which is M, but not including the position 7. So that returns the slice, basically, in the original string from index 2 up to index 7. Index 7 is the index of M. So basically index 7 is not in fact returned. The upper index in substring is not returned. If we only pass one parameter, it basically returns the rest of the string from that parameter. So for instance, if I'm asking give me from the index 2 up to the end of the string, it will return statement. It's basically from the position 2 up to the end of the string. Strings are immutable. Basically, there are no methods to change strings within the string class. So every single method that we are actually implementing, like substring or we are using, they actually return new strings. So even if we are assigning them the new string to the same variable, it will create a new string and the variable will be reassigned a new address, the address of the new string. So every new assignment will result into a new string, and we have in the old variable a reference to that new string. The plus operator is a shortcut for concatenation. So, for instance, we used it in the system out println statements. You can concatenate multiple strings and it results into a new string. So, for instance, if you concatenate welcome to Java, it will have in the variable message welcome to Java. Similarly, if you concatenate a string and a number, it will concatenate from left to right the strings and the numbers. So S will become chapter 2. If you want to do any numeric computations, you have to put them within parentheses internally, because otherwise it will actually do concatenation. So let me show you an example. This is a very important example. Let's assume that we have two integer variables. Integer I is equal with 9 and integer j is equal with 12. If at the end of this string, like S, a statement, we concatenate I and j, we actually get a statement 9, 12. Let's say that we actually want to compute the sum of 9 and 12, we have to put it within parentheses. So now a statement will be followed by 21. Because string plus integer is concatenation, and integer plus integer is actually summation in integer as numbers. Okay, so that is concatenation. There are many useful string functions, and you should actually start using them all. You should try one by one to see what each one of them does. So character at basically returns one character out of the string. Equals checks if two strings are actually equal. Equals ignore case does the same thing for basically strings that may be actually different in some characters but in lower and uppercase. Compare to returns 0 if the two strings are equal, or it returns the lexicographical distance between the two strings if the two strings are not equal. Starts with checks if the string that we pass as a parameter is a prefix of the string for which we invoke this method. Ends with checks if a string ends with the inner strings. We are going to do these examples one by one as we talk about each one of these functions. So let's start with s equals. We already talked about character at. So s equals returns true if two strings are equal, they have the same letters and the same sequence, or false otherwise. Let's actually experiment with them. So let's assume that we have two strings, s and another string, s2. And they are both a statement. And we can compare them with s dot equals s2. So we can see already that the two strings are basically the same sequence of characters. Therefore, we can compare them, and it will actually tell us that yes, the two strings are equal, are basically the same sequence. If any one of them basically is different, if we try to compare a state with a statement, it will basically say false. Similarly, the compare to returns 0 if the two strings are the same, or it returns a value which is the lexicographical distance between the two strings. Let's say that we compare A and B. A is less than B with 1. So if we compare A with B, it will tell us that there is a distance between the two letters A and B of -1. A is before B with 1 character. And similarly, if you actually have longer distance between A and D, it's -3 instead of -1. So it gives you the lexicographical distance. It basically finds the first position where the characters are different. So as long as they are the same, those are not compared. The distance is 0. But it finds the first position where the characters are different, and it tells me what's the distance between those two characters in Unicode. Okay? There are also special characters, and we talked about them earlier today in the previous lecture. /n, if you have a new line character, you would specify it not by entering a new line, by entering /n is a special character. /t stands for tab, and slash double quotes will basically include double quotes within a string. Otherwise, if you don't have the escape character for double quotes, then it will think that the double quotes are the end of the beginning of the string. So if you want the double quotes to actually be part of the string, you need to escape them before you include them in code. We already talked about the character at index, which basically returns the character at an index within the length of the entire string. And then we have the the length method. The length method gives us how many letters are in that string. So for instance, if we have a string of several characters, we can actually find how many characters are in that string by invoking the length method. So the length method in this case it will return 4 because there are 4 letters in that. Now if we want to extract the characters will start with index 0 and they will end with index the length -1. So in our case, basically, although the string has a length of 4, the indices for the characters in that string end at 3. So the length of the string is actually the index of the last character is the length of the string -1. And that is here in the lecture notes. You will find that although the message length is 15, the index of the last A in Welcome to Java is 14. Okay. We already learned how to read strings from the console. We can use a scanner object that we initialize with the system.inputString. Reading characters from the console can basically be done by reading a string and then extracting the character at index 0 if we only need that one character. And this is basically connected to our previous example, the conversion menu that we basically implemented earlier today and is part of your lab for today. I will revert back to that state to show you one more time how to read one single character from the console. We didn't record that part in order to be a challenge for your lab for today, but I can show it to you once and you can basically use it for your lab for today. We did a lot of implementation today, so there is a lot of code to undo before I can show you that specific code. Control Z allows you to undo a specific code that you wrote earlier today, which it looks like we already deleted, in fact, that specific code. So that's okay. You will have to do it from scratch. Now, when you compare strings, you should never use the double equal operator, because instead of comparing the strings, it will compare their memory addresses, not the actual strings. Always use the dot equals method, which is supplied by the string class. And I will show you an example. For instance, let's assume that we have two words, word 1 and word 2. They are two strings. They both contain the same letters, hello and hello. But if we compare them with double equal operator, it will print false. And the reason why is that these are two words at different addresses in memory. So remember again that these are references. Word1 and word2 are in fact the addresses of two objects in memory. So these are not primitive types. There are only 8 primitive types in Java, and string is not one of them. We have 4 number types, 2 real types, character and boolean. Therefore, there is absolutely we basically need to compare strings not with a double equal operator that compares their addresses, but we have to compare them with the dot equals. Dot equals, in fact, compares the character by character, the two strings. So let's actually do this test. It's very important that we realize the difference between the double equal and dot equals. So we define two strings, string S1, which is equal with a new string for the word hello, and string S2, which is a new string for the same word hello, and we define a Boolean value, let's call it is, and based on the value, if S1 is the same address with S2, we will print true. Otherwise, we will print false. So again, the thing is that these are not the same address. So it will actually, if we want to ask if S1 and S2 are the same string, we have to use S1 dot equals S2. In that case, we actually compare the characters within the two strings, and they are the same. They are both the string hello. So the difference between the two operators, instead of using if S1 is the same address with S2, we are using if equals. And they are basically different. One compares two references, the other one compares the two objects at those locations. It compares the characters in the string S1 with the characters in the string S2. However, there is another issue. In Java, if you use constants directly to assign to strings, those are a different type of strings. Those are intern strings. Only one instance of the actual string will be stored in memory. So if we do compare them with the double equal operator, the answer that will be returned will be true. Yes, they are the same reference because they are both assigned the same one single constant hello from memory. So intent strings are strings that are collected during parsing. Basically, it parses the program, it collects all of these constants like hello, and it only stores them once. So if you assign that hello constant both word1 and word2, word1 and word2 have the address of the same constant. They are basically two references to the same object. So this is the only case when it actually, using the double equal, it returns the same result as using the dot equals, because that will also return true. But this is just an implementation decision that Java made when they basically invented the constants that are only selected once or only created once in memory. For comparing strings, you should really use equals ignore case, compare to, which returns 0 if the two strings are equal, a value greater than 0 if the first string is greater than the string passed as parameter, or a negative value if the string passed as a parameter is bigger. And the equivalent method for ignoring the case. Then we have the start with, which checks if a string is a prefix of another string. So for instance, if you have a string like S1 and you want to check if the string S1 starts with H. And in this case, it will print that yes, that is true. The string S1 starts with H. And you can actually say, does it start with he? And that is also true. Hello starts with he. Okay. What about obtaining substrings? Earlier we saw that basically if you give a range like for instance from index 0 up to index 11, not including 11, we can extract a slice. Like welcome to will be returned by message.substring between position 0 and 11. If you only give one parameter, then it will return the rest of the string from that parameter. So for instance, the substring starting with position 11 returns just Java. If you want to find characters or substrings within strings, there exists another method. It's called index of. You pass either the parameter or the character and the starting index from which you are searching that, the index, the first index occurrence of the character ch. So let's basically ask, let's try, give me the index of the character, let's say L. It gives me, in this case, 2. The first index of L, starting from position 0, is 2. If I'm asking, give me starting from position 3, then it basically gives me the second L because it advanced past the first L. Okay? And it also works for strings. So basically it works for characters. It also works in the same way for strings. It returns the first occurrence of that character or of that string from that position. So for instance, if I want to find the first index of space in Kim Jones, it will return 3. If I want basically to split a string like Kim Jones into the first name and the last name, I can find the position of the space and then extract the slice from position 0 to index k and from index k plus 1 to the end of the string. And these are very useful methods if you want to basically extract from a string any parts. If you read numbers and you want, or strings that represent numbers, or integer strings that represent doubles or integers, you basically can use the static methods parseInt and parseDouble from the integer and double classes to parse these strings into numbers. Because in Java you cannot by default assign numbers to strings to integer or double variables. So let me show you an example again. Let's assume that we have a variable of the type integer and I want to assign it the number 1 from a string. By default I cannot do that because 1 is a string, but I can do integer dot parseInt the string that contains the character 1, or even like any number that represents an integer. That will succeed and it will extract, in this case, 15,678. Finally, one thing that you saw in the lab today is how do you print, for instance, a series of numbers formatted to a specific specifier. Like for instance, most useful is for extracting exactly n digits out of a float number, out of a real. So you can specify, you can do it with the printf statement. The printf statement takes two parameters: the format, which is a string consisting of substrings and format specifiers, which basically start with a %sign, and items. Let's see a format specifier. %b stands for a Boolean value. %c stands for a character. %d stands for a decimal number. %e stands for a number in standard notation, which basically starts with 1 digit, dot, the decimal dot, any number of digits, and then the exponent. And %s stands for a string. So for instance, if you have a double and an integer and you want to print the integer on some number of spaces followed by the double on with 2 digits after the decimal point, you can do it by specifying in the format the substring count is followed by the %d for the integer, and the amount is followed by percent dot period 2f. That says that from the amount, no matter how many digits are in that amount, I want only and exactly 2 digits. Okay? So let's actually try to do this as a last exercise for today. Let's assume that we have random values. We have a double variable d, which is math.random, and we want to print from that only the first 2 digits. If we just print d, it will print the entire random number. It's basically a very long number. If we want to print that number, let's say on 2 or on 3, no, let's say 5 spaces aligned to the right with 2 digits after the decimal point. That basically will print the number 100. It basically, in this case, it also rounded that number to 1.0 because it was probably very, very close to 1, because you basically get values between 0 and 1, not including 1, but it was very, 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 very close to 1. So in fact it rounded it to 1 in order to show it to us with 2 digits after the decimal point. That's okay for today. So let's assume that we want 3 digits after the decimal point. That can be easily fixed by specifying the number of digits